Bismillahirrahmanirrahim. My dear Assalamu alaikum. You are watching Math with Yasir Arfad, and we are going to a very important question of integration here, that is integration of tangent inverse x of dx. Here we have to apply the by parts formula here. In my last videos, in my last lectures, we have discussed in detail how to apply the by parts and in which situation we have discussed the by parts. If you have any basic issues in the by parts, please see those all videos. Here, this is tangent inverse x of dx. So we have to take out u, that is tangent inverse x, and v, it is equals to 1. And we have already discussed that we have to find out the derivative of u and the integration of v, and then we have to apply the by parts there. So this is derivative of u. So the tangent inverse, the derivative of tangent inverse is 1 plus x square, and here integration of 1, that is x, this is x. U, it is tangent inverse, and v, it is 1. If we have given one function there and we have to apply the by parts there, so then we have to take out u. U cannot be equal to 1 because the derivative of u will be 0, then the whole situation, whole function will be equal to 0. So therefore, whenever we have to apply the by parts there and the one function is given, then we have to take out that function is u, and v, it is equals to 1. And the derivative of u, that is tangent inverse, it is 1 over 1 plus x square, and the integration of 1 is x. Now we have to apply the by parts using by parts. That is u into v, u as it is, integration of v minus main integration, derivative of u, integration of v of dx. This is the formula of by parts. Now apply this formula on the given question here. U as it is, that means tangent inverse as it is. The integration of v, that is 1, minus main integration, derivative of u, that is tangent inverse x, integration of v, that is 1 of dx. So here tangent inverse 1 as it is, integration of 1 is x, minus main integration, derivative of tangent inverse is 1 over 1 plus x square, and the integration of x is 1 is x. So this is x into tangent inverse x minus 1 over 1 plus x square dx. Now this is the turn to find out the integration of, to find out the main integration here. So this is 1 plus x square, 1 plus x square, its derivative here 2x, here x is given, it means this is the function and this is its derivative. So we have to suppose that t is equals to 1 plus x square. And now differentiate with respect to x here. So this is dt over dx, it is equals to 2x. Constant can be transferable here. So this is dx is equals to, 2 is equals to x of dx. Or we can say dt over 2, it is equals to x dx. So here, now come to this point here. This is x, tangent inverse remains same, minus main integration. 1 plus x square, it is equals to t, so this is 1 over 2. And x dx, it is equals to dt over 2. Now x tangent inverse x minus 1 upon 2. Integration of 1 upon t, it is ln t plus c. C is the constant of integration. Dear students, 1 upon t, we have a formula. 1 upon t, its integration is ln t. So just we have to put the value here. T, it is 1 plus x square plus c. So this is the answer of this question. Dear students, it is a very important question. It came in a special exam which held in 2022 in January. Thank you so much, dear students. If you like this video, please share it and subscribe my channel Math with Yasir Arafat. Allah Hafiz.